Hi everyone. I'm out here in my garden. The sun is shining nicely, so today I didn't prepare a workshop video for you, but rather a garden video. It's going to be about something electrical. You can see all sorts of interesting devices next to me here. Here you see an aluminum sphere and a big coil. This is a receiver device. This receiver collects electromagnetic waves from its surroundings, and over there you can see a blue instrument, which is used to measure how much electrical signal can be gathered with this receiving device. The receiver unit, a nice big aluminum sphere, which I made by wrapping a small soccer ball in aluminum foil. Here is a long coil. This coil is about a little over a meter long. This is a Tesla transmitter coil. It has a very simple little electronic setup. It's roughly the same as the big one, in that it also has a coil and a sphere on top. This is a golf ball that I wrapped in aluminum foil. Bought, in quotes, a factory-made little Tesla from China. Coil as well, or a small Tesla circuit, this is what it looks like. This device, it needs 12 volts. This one needs 16 volts. So I put together a lithium-ion battery pack. It has 4 lithium-ion cells inside. Each cell is 4 volts, so I can get 16 volts out of one connector through here, and here is another connector, through which I can get 12 volts. With this, we can basically capture the energy emitted by the Tesla coils, if these light up, or more precisely, if this compact fluorescent doesn't light up. Then obviously, in that area, there's a fairly high amount of energy, or quite a lot of energy present. This consists of 2 ceramic capacitors here. I put in Schottky diodes. There are 4 Schottky diodes, and 2 small buffer capacitors, 2 electrolytic capacitors. 3 wires come out of this little device. This wire here, you can see the end of it there, will be the grounding wire. And for grounding, here is an almost 2-meter long aluminum rod, as you can see here. And on the other end of the wire, let me show you here, there are actually 2 banana plugs attached, which I will connect to the instrument. This will then show the amount of energy that is being produced. Here is this nice, long, shiny aluminum rod. I previously drilled a hole in the ground in order to insert the aluminum rod, and this will serve as the grounding for the entire setup. So basically, this small circuit right here is made up of a few different capacitors and diodes, which are all connected together in a specific way to make the circuit function properly. This long coil right here is connected, with the aluminum sphere positioned on top, and what it picks up from the electromagnetic field that is present all around us, this small circuit is able to direct it all by itself, automatically, and through this wire it eventually arrives here, and well, we can observe a fluctuating voltage that varies between about 90, 100, and up to 80 millivolts. We can clearly see that this entire structure, when considered as a whole, does not collect or gather a huge or significant amount of energy overall. Practically speaking, I really wouldn't be able to power even a small LED light with it, but for demonstration purposes, I have placed a Tesla coil right here, which I actually built myself from scratch. So now I'll go ahead and turn it on. This device here is a Tesla transmitter coil, and over here is a Tesla receiver coil. Here you can clearly see the multimeter. I have set the multimeter to the 200-volt range for accurate measurement. Now comes an interesting and exciting part. I'm going to turn on the transmitter coil. Watch the instrument closely. It's pretty intense. The instrument is currently showing 56 volts, 56.5 volts. So earlier, in the electromagnetic field around us, we saw that it could only pick up a few hundred millivolts. Not even that, just 90 millivolts. But now, the instrument is showing 55 to 57 volts. Let's see what that's enough for. I'll connect this LED. I'll try to create a bit of shade. I hope the camera can see that the LED is lighting up. However, the previous 55 volts dropped down to 5 volts. There are 2 680 ohm resistors connected in series with the LED, so that means roughly 1 milliampere of current, or about 1 to 2 milliamperes of current. That's about what we've managed to collect. But in exchange, I had to invest a lot of watts here. From this lithium-ion battery, about 1 ampere is coming out. I'm drawing about 12 watts from the battery, and on the other side, I can collect 1 milliamp or 2 milliamps at 5 volts, which means I have 5 milliwatts. So here at the transmitter, there's about 10 to 12 watts, and on the other side, just 1 to 2 milliwatts. So only about 1,000th of the radiated power makes it through. Actually, not even that much. Meanwhile, I brought over this compact fluorescent lamp, turned on the transmitter coil, and you can see that the receiver is collecting about 5 volts. And the compact fluorescent lamp, well, I can see that it's glowing, but honestly, in this sunlight, You probably can't really see it, but trust me, I can see a bit of a glow, so this compact fluorescent tube is able to pick up some energy and light up as a result. Now I'm turning off the transmitter coil, and naturally the LED isn't lighting up now, and there's only about 2 volts left in the capacitor. What we're actually seeing now isn't what this coil is picking up, but rather how much residual energy is left in the capacitor. Here is the little Chinese wonder, the small Chinese Tesla coil, and I'm going to set this up as well. I'll need the 16-volt connector for this, but last time I got a nasty shock, so in the meantime I have to hold down my little transmitter coil with this pen. It's working again, since now the meter shows 7 volts, earlier it showed 5 volts, and if I remove the LED, then instead of the previous 55 to 56 volts, the voltage now goes up to 72 to 74 to 75 volts. So a pretty significant amount of voltage is generated, but there's no current behind it. I'll put the LED back on. You see, the LED lights up again, but only about 6 volts of voltage is generated. So it's the same situation here. This is a transmitter, this is a receiver, and I'm able to transfer energy from here to here, though with quite a lot of loss, but it still works. I'll show you the compact fluorescent lamp here as well. I'll try to shield it with my hand, but you probably can't see it in the sunlight, though the compact fluorescent is glowing a little. When I put this compact fluorescent lamp here, I also noticed just for a brief moment that the voltage dropped slightly on the meter. If we have a source from which we can actually extract energy, then there will be real measurable energy extraction happening. It's also interesting to see how much current it can deliver. Earlier, we saw 75 volts, 55 volts, 5 volts on the meter. I'm switching the meter to ammeter mode. It's set to 20 milliamps. We can basically generate 0 milliamps of current. Let me check, maybe there's a better setting? Even at the 2 milliamp setting, the meter still shows 0. But I wonder what it will show if I turn my transmitter coil back on. When the transmitter coil is operating, the system is capable of a 3 milliamp current. So this little Chinese transmitter can transfer enough to the large coil from this distance to generate 3 milliamps. We saw the voltage too, for example, 20 times 5. Let's say 3 milliamps, that's 15 milliwatts. I'll check what the other transmitter can do, and as you can see, because my transmitter can only transfer 1.5 milliamps from here to there, although the distance is also a factor. The distance is a bit greater. There's another part to the experiment. I brought another coil, just showing it to the camera here. It's also a nice long coil. I'll set it down here like this, and what I'm going to do is connect the grounding wire over here. I'll clip it with the alligator clip and connect it to this. I'm doing this experiment to find out what happens if I don't use a ground rod, but instead use this coil. Turning on the little Chinese maid, testing the coil, and as you can see, I managed to generate just a little bit more voltage than before. Earlier, with the grounding rod, it was around 75 or 76 volts. Now, it's a few volts higher than that. But let's check what the LED does with the setup. Now you can see that the LED is lighting up quite enthusiastically. While earlier the meter showed between 5 and 6 volts, now it's at 17 volts. Now I have to turn the meter back on again because it went into energy saving mode, so now it's showing 15 volts. So this is more efficient. If I don't measure this relative to the ground, but relative to this, then the meter shows a bit more. For example, look, if I touch this grounding, well, not grounding, but this coil, it changes as well. Probably what's happening is that this transmitter isn't just coupling energy into this one, but into this one as well, and that's why I have a higher voltage now. I'll try it with my own transmitter setup too. The LED also works perfectly fine when I turn on the transmitter circuit, or rather, the LED lights up as expected. There's only about 3.5 volts present, which really isn't much at all. And as you saw earlier, you can actually collect a little bit more electrical energy in this way if the ground probe is there and properly connected. This whole thing probably also depends on what frequency it's transmitting at, what its specific design is, and so on and so forth, how much energy we're actually putting in, and other related factors. But this experiment was just to show that in reality, it works in the air as demonstrated. Energy transfer through the air, the efficiency is terrible, as we can see, for example, with electric toothbrushes. There are some toothbrushes that you just set down, and you can charge their batteries without any wires at all. There are also electric chargers, these induction chargers, that charge phones. You can transfer energy through the air, but it's much better if there's a better medium, like an iron core, ferrite, or something else. But it is possible through the air as well. It's just that the efficiency is extremely poor. Of course, this was to be expected, that something like this would happen, since engineers, maybe even tens of thousands of them, use instruments every day, and they practically scan the entire frequency range with their instruments, from DC level up to tens of gigahertz, or even 100 gigahertz. They haven't found any energy source in the measured frequency range, and since they haven't found such an energy source, I haven't found one either. What you see here comes from TVs, radios, phones, from the machine itself. From GSM phones, Wi Fi, and the sun's magnetic activity, it's a truly negligible amount of energy. The LED does not light up with it. Right now, it is only showing 2 volts because there is still some electrical energy left in the electrical capacitors, in the small, uneven, and rather simple electronic circuit. So that's how it is. Thank you very much for watching my video, and please consider subscribing to my channel for more interesting content. Bye!